Students, let's start with the part 5 of chapter similarity. In part 5 of similarity, we are going to study property of an angle bisector of a triangle. Now, this angle bisector is nothing but we are going to study the theorem of it. Now, what this theorem says, the bisector of an angle of a triangle. Now the bisector of an angle of a triangle. So of course we need to draw a triangle first to understand it. So here first I am drawing a triangle. Okay. So here the triangle is ready as per the statement. So the bisector of an angle of a triangle. Triangle is ready. Let's draw the bisector. So I am drawing a bisector from here. Okay. For example, I am giving this name as A, B, C. And here I am writing CE. So can you say that ray CE? Ray CE is a bisector of angle ACB. So these angles have been cut into two equal halves because of the bisector. Now what the theorem says, the bisector of an angle of a triangle. So there is one triangle, there is a bisector which divides the side opposite to the angle. This is the angle and this side opposite to this angle is what? AB. So it is going to divide the side opposite to the angle, means AB is divided into AE and EB. Okay, it is divided into AE and EB in the ratio of the remaining side. Now this is the one side of the triangle which is already divided into two equal halves, AE into AB, and in the ratio of the remaining side. Which are the two remaining side of the triangle now? That is AC and CB. So what this theorem says you to prove, given, I am going to write first what is there, what the diagram says you. First we are going to write that as a given. So can I write that in triangle ABC, angle C, which angle? Angle C is what? Angle C is what? Bisector. So angle C intersects sec AB in the point at which point it intersect? It intersect at point E. So can you write this? What is seen in the diagram? I read the statement and the diagram was drawn as per the statement, and what is seen in the diagram I have written here, that in triangle ABC, angle C which intersects, means it cuts AB in point E. Okay. Now what we need to prove? To prove is what? A statement. A statement says what? Triangle divides the side opposite to the angle. So this is the side opposite to the angle. It is going to divide this side in the ratio of the remaining side. Remaining side is what? AC and CB. So what you need to prove? That AE upon EB is equals to AC upon CB. Right? You need to prove this. Now to prove this, you need to do one simple construction. So let's see what construction I am doing. Be attentive and listen to the construction. Nothing I am going to do. I am going to draw a line parallel to C. I am going to line a line parallel to C. So see, I am drawing a line which is parallel to C. Okay, and the line which is parallel to C is going to meet a line. I am going to draw a line parallel to C which passes through B, and it intersect. It is going to meet whom? Little slant this line should be, not straight. So which is going to pass through B, okay, and it is going to meet this line AC if you extend it. Okay, my diagram will go little up, so this you try to understand, and this will be your point D. Okay, can you see? Okay, I'll make little darker. Okay, so what construction I did? I did what? A line which is parallel to C. So can you see a line BD? Can you see line BD? A line C is parallel to BD. This line passes through B and which intersect AC at point D. Clear? So we are going to write this as a statement that what? Draw a line parallel to ray C. Clear? First thing. And from where it is passing? This line is passing through the point B. Correct? And if you extend AC, what you extend? AC. If you are going to extend AC, so as to intersect, it is going to intersect. If you extend AC, so it is going to intersect it at point B. So these three steps are clear. Given comes from the basic diagram, what the statement says. To prove comes from the statement, and construction is something what additional we did, right, in order to get a to prove. Clear? What I did nothing I did, just draw a line C, just draw a line DB, okay, which is parallel to C, which passes through B, and if you extend AC, it is going to meet at point D. Clear? Now let's start to prove. How simple this theorem is. Let's start proving it. Proof. How I'm going to prove it? First step. Can you see that C and BD are parallel to each other? So can I write that ray C is parallel? Can I say that ray CE is parallel to ray DB? Can I write this? And can I say this, that if these two lines are parallel, if these two rays are parallel, can I say that AD is a transversal? Can you observe? Two lines are parallel and AD is what? Transversal. So I am writing here AD is a transversal. Clear? Now if this and this line are parallel and this is a transversal, so can I say that angle ACE, this angle which I have done this blue circle, and CDB, this angle, they both are corresponding angles. Can you see these angles? Can I say that these two angles are corresponding angles? Yes. So can I write angle, what I'm going to write, ACE, this angle ACE is congruent to angle CDB. Why they are congruent? Because what they are corresponding angles, right? Give this as statement number 1. Now second, I'm going to show you something here with this red angle. Can you see? If I say that BC is a transversal, so can I say that this angle and this angle can be congruent? Can I say? Observe it. This are making what? Z. And these two angles are which type of angle? These two angles are alternate angle. Yes or no? So now I'm going to take BC is a transversal. So if I'm taking BC as a transversal, can I write that angle C, it is what? ECB. Can I write angle ECB is congruent to angle CBD. Why? What is the reason? They are what? Alternate angle. Correct? This is your statement number 2. Correct? Can you understand this two? These two blue colors angles are nothing but they are corresponding angle, and these two are what? Alternate angle. Now what is written here says you one more thing, that angle C intersect AB, okay, in point D. So if this C is getting intersecting AB into at point D, so can I say that angle ACE is congruent to ECB? Why? These two angles, if this is getting cut into equal parts, so these angles are also going to cut into 2 equal halves. This C is cutting this angle into 2 equal halves. So can I say these both angles are also congruent as per the given. Can I say? So I'll write here. What I'm going to write that angle ACE is congruent to angle ECB. From where I got this? From given. I am getting this from given. Correct? Can I give this as statement number 3? Now observe first, second and third statement. This is equals to this. This is equals to this, and this both are equal to each other. So what can I conclude from this? What can I conclude from this? Can I conclude? See, if your ACE, where is ACE? Your and your. Can you see? Okay, is equals to CBD. This both. Correct? So if this is equals, if this part is equals to this, this is equals to this, this is equals to this. So ACE, ACE, CBD, CBD. So and ECD, ECB. So can I conclude this that CBD, where is CBD? This part is equals to CDB. Where is CDB? CBD. That is this. And CDB. So if these two, can I say they are equal? Can I say? Because of 1, 2 and 3. So what I'm going to write here, that from 1, 2 and 3. What I can state from 1, 2 and 3, that if this angle is equals to this, this is equals to this, this is equals to this, then these two both can be equal to each other. So can I write angle CBD is congruent to angle CDB. B and D, they both are congruent. From where I got? From 1, 2 and 3. Attentively look at all these 3 statements. Now you tell me one thing. If these both the base angles are equal, so can I conclude that my triangle CBD is an isosceles triangle? Can I conclude? See, the base angles are same. So can I conclude CBD, triangle CBD is an isosceles triangle? Yes, I can conclude, because both the base angles are same. If the base in isosceles triangle, if the base angles are same, can I say that CB is congruent to CD? Yes. If CB is congruent to CD, can I write CB is equals to CD? Yes, I can write. Okay, I will give this as statement number 4. Correct? Now I will go in triangle, full triangle ABD. Can you see ABD? You see ABD? Now CE is parallel to BD. Correct? What you say? CE is parallel to BD. So if these two lines are parallel, so what happens if a line is parallel to the third side of a triangle? You have already learned this, that AC upon CD can be equals to AE upon EB. Which property I have applied this? This is what? From BPT. Correct? If this line is parallel to this line, can I say that AC upon CD is equals to AE upon ED? But look at my 2 proof. I want to prove that AE upon EB. That I got. AC upon CD I don't want. I want AC upon CB. So here if you look, in the place of CD, can I write CB? Yes, I can write, because CB and CD are congruent. From where? Because they are isosceles triangles, so both the sides are congruent. So what I will do, only in the place of AC I'll write AC. In the place of CD I am going to write what? CB is equals to AE upon EB. And this I got from where? From 4. And this I wanted to prove. So it is hence proved. Clear? You can take a screenshot if you need, but try to understand it well. Nothing I did. First, corresponding angles, alternate angles. These two angles are equal because of the given. I went in this triangle. If this is equals to this, this is equals to this, this is equals to this both are equal to each other. This is my isosceles triangle. These two sides are equal. Applied BPT and hence proved. Okay.